Hi folks, welcome to 6.2 Trigonometric Equations. So today we're going to focus on learning how to solve a variety of trig equations, and I'll try and go over a few common cases that we will tend to see. But one thing is for sure, if you don't know your unit circle, make sure that you go ahead and spend some time refamiliarizing yourself with the unit circle, and it might even be helpful to pull up a unit circle on your laptop or from your notebook to have with you as we go through these examples. Okay, so I'll give you a moment to do that. Pause here if you need to, otherwise we're going to continue on to example number 1. Okay, so example number 1, we've got cosine x equals -1. Now, one of the things I want to remind you of is that when we have a trig function, like we do right here, this cosine x, the x is being cosigned. And if we want to get rid of it, we can't just divide the cosine away, but instead what we do is we do the inverse cosine. And whatever we do to one side, we're gonna have to do to the other. So we're going to inverse cosine both sides. This will give us inverse cosine of cosine x equals cosine of -1. You might have also heard cosine x inverse cosine as arc cosine. Okay, every instructor has a different preference, different textbooks have different preferences, but arc cosine and inverse cosine are the same thing. Okay, so why is that useful to us? It's useful to us because this arc cosine and the cosine are just going to leave us with the x on the left-hand side. And then what we really need to find out is what is the inverse cosine of -1. Now I want to take the time to write out what this sentence is asking me for so that we can use that as a way to translate all the other future examples. So this part, arc cosine of -1, is really saying what angle has an x value of -1. Okay, and let me just highlight what the different parts represent in this sentence. So this -1 right here from the arc cosine, that tells me to find the angle. This cosine part tells me to go ahead and find the x value. And last but not least, this -1 corresponds to that -1. So the way we read this, we start with the orange part, what angle has an x value of -1. And so if we take a look at our unit circle, and I'll sketch a quick picture right here, and we want to think about the angle that has an x value of -1. That's going to be this point right here. And that point, at that angle, we have x equals 180 degrees. We could also say that this is our answer in degrees, but we want our answer in radians, and that is the same as pi. So there's our degrees answer, our radians answer, and both of those would be acceptable for this stage, but by the time we get to the end of this section, I really want us to be comfortable with the radians measure. We don't tend to see the degrees a lot in Calc 1 and Calc 2, which is why I really want us to get used to doing working with radians now. Okay, so that's it as a warm-up solving equations. It's a review of how to find things on the unit circle. And let's go ahead and move on to example number 2. Okay, example number 2. So here we have tangent theta equals root 3. And the way we're going to handle this, we're going to do the same thing we did up here with the arc cosine or the inverse cosine on both sides, except this time I'm going to set it up as an inverse tangent on both sides. So inverse tangent of tangent theta equals inverse tangent of root 3. Now, if we translate this sentence, we're going to start the same way. We're going to look for this -1 part to tell us that we're looking for an angle. Okay? So let me get to that next line first. This arctan and that tan go away. We get theta equals arctan of root 3. So this -1 tells us what angle has a tangent. Now, tangent actually tells us to find the y over x value. So it's a little bit different than the cosine. So what angle has a y over x value of, what's the value we want to find, is this root 3. So what angle has a y over x value of root 3? That's the question that we're trying to answer. Now, let's take a look at our unit circle to find out. So if we go back to our unit circle and we look around the unit circle, we will find that at theta equals pi over 3, we're going to have these certain x and y values. The y value there is root 3 over 2, and the x value there is 1/2. And I know that doesn't look like root 3 over 2, but if we simplify this, we'll get root 3 over 2, which just gives us root 3. Okay, so our angle here is going to be pi over 3. Now, again, I want to move us away from the degrees and get us comfortable with having radians as our answer. So theta equals pi over 3 is our answer. Now, it turns out, though, that there is another angle on the unit circle that has the same y divided by x value. And so let's go ahead and see where else we might find that. If I keep looking around the unit circle, I'm going to get to a place where I realize there's a negative root 3 over 2 as the y value and a negative 1/2 as the x value. And that is going to simplify to a root 3. So this angle, wherever that is, also has a tangent of root 3. And if we look at our unit circle, we're going to find that this angle happens at not pi over 3, but 4 pi over 3. And so if you look at the questions carefully that you're going to see both on your homework and on WebAssign and on the tests, sometimes I'm going to say, I want you to find all of the answers if you go one time around the unit circle. And the way I would tell you that is I would say to list all answers from 0 to 2 pi. So just one time around the unit circle. And if you go one time around the unit circle, you'll find that your answers are going to be pi over 3 and 4 pi over 3. And so we're going to say that this one right here is our final answer. We have to list both of them, okay? So a little bit of a step up from our example number 1. Okay, let's go ahead and move on to example number 3. So we're getting a few more terms here. Things are looking a little bit more complicated, but let's just take it step by step. So I'm going to go ahead and try and get sine 3 theta all by itself. And I'm going to go ahead and take this term, I'm going to subtract it to that side. And so I'll get 2 sine of 3 theta equals negative root 2. And then I'm going to go ahead and take this 2 and I'm going to divide it over. And so I'll get sine of 3 theta equals negative root 2 over 2. Now, I'm going to pause for a moment here, and I'm going to use a u substitution to help us simplify this problem a little bit. I'm going to have us set u equal to 3 theta, and then we're going to plug the u back in later on. So right now our question looks like sine of u equals negative root 2 over 2. And so what that means is you're going to arc sine both sides. So u equals arc sine of negative root 2 over 2. Okay? And there's nothing in front of the u because when I arc sine the sine, those are going to undo each other and all I'll be left with is the u. So I just didn't write that step out. Okay, now what this is saying is find an angle with a y value of negative root 2 over 2. And again, if I break that down, this part says find the angle. This part, sine, says find the y value. And negative root 2 over 2 is the coordinate that I'm looking for. And so let's imagine the first time through this problem that we're actually looking for the angles that fulfill this. And we want to make sure we look all the way around the unit circle. So from 0 to 2 pi. And when I look at the unit circle, I'm going to realize that I have 2 values for u. U can be at 5 pi over 4. Or u could be 7 pi over 4. Both of those angles have a y value of negative root 2 over 2. Now remember, we're not looking for u, we're looking for theta. So everywhere I see a u, I'm going to go ahead and put back in the 3 theta that we subbed out in the beginning. So this is going to give me 3 theta equals 5 pi over 4. And this one will give me 3 theta equals 7 pi over 4. Now, if I'm just looking for answers that go one time around the unit circle, I'm going to go ahead and take this theta. I'm going to divide by the 3, so I'll get theta equals 5 pi over 12. And if I do the same thing on the second one, I'll get theta equals 7 pi over 12. Okay, now this will give me 2 of my answers as I go around the unit circle. 5 pi over 12, 7 pi over 12. But that is not all of our answers. We need to find out how many more answers there are as we go around the unit circle. And so what I'm going to do is I'm going to go back to this statement right here, and I'm going to add on something else to it. So 3 theta equals 5 pi over 4 plus, I know that the period of sine is 2 pi, so I'm going to add the 2 pi, and I'm going to write a letter n here. Now this n is just an integer. Okay, this n is just an integer. So the n allows me to count as many times around the unit circle as I want to. And I'm going to do the same thing here. I'm going to divide that 3 away, but now I have to divide it out from the first term, and I have to divide it by the second term. Now what's handy about this is this will now tell me how to keep adding until I'm all the way back to 2 pi. So I could have theta equals 5 pi over 12. I could have 5 pi over 12 plus 2 pi over 3. I could have 5 pi over 12 plus 4 pi over 3. And I could keep going until I get to 2 pi. If I go back to the second answer and I do the same thing, 3 theta equals 7 pi over 4 plus 2 pi n. And then I divide by the 3, I'll get 7 pi over 12 plus 2 pi over 3n. And again, this one will tell me how many times to count around the unit circle. So I could have 7 pi over 12. I could have 7 pi over 12 plus 2 pi over 3. I could have 7 pi over 12 plus 4 pi over 3. And I would just keep going until I reached 2 pi. Then I would know I had all of my answers. Okay, so let's take a quick pause here, and we'll consider this part 1 of the video. And when we come back for part 2, we'll take